So last time we dealt with adding and subtracting rational numbers. Now we'll talk about multiplying and dividing rational numbers. So when the signs are the same, either both positive or both negative, the answer is positive. But when the signs are different, one is positive and one is negative, doesn't matter which one's first or second, just if they're different, then the answer is negative. So let's keep that in mind as we go through this. Okay, so as I look at number 1, I may not know the answer off the top of my head, but I know that the answer is going to be negative because I have a negative divided by a positive. So since the signs are different, I know the answer has to be negative. Now it turns out that 65 divided by 13 is negative 5. Okay, on number 2, they're both negative, so the signs are the same. So I know the answer, even though they both are negative, since they're the same, the answer is going to be positive. 120 divided by 20. If it helps you, just ignore the zeros. Since they both have one, you can ignore them. What's 12 divided by 2? And that would be 6. Okay, number 3, we have a negative times a positive. Negative 6 times positive 4, so I know the answer will be negative. And 6 times 4 is 24. Okay, 4, they're both negative, so they have the same sign, so the answer is positive. 5 times 10 is 50. Okay, now as you get to 5 and 6, just as we talked about with adding and subtracting, multiplying and dividing are in the same step with the order of operations. You're just instructed to do them from left to right. Now, honestly, there are times it actually doesn't make a difference whether you do it from left to right or not, but there's times it does. So to make sure you get it right every time, just always do it from left to right. So I start with 6 times negative 5. That's a positive times a negative. Those are different signs. So I know the answer will be negative. And 6 times 5 is 30. But now I have a negative divided by a negative. So the two signs are the same. So I know the result will be positive. 30 divided by 3 is 10. Okay, we have a negative divided by a negative. So the answer will be positive. 14 divided by 2 is positive 7. Now I have a positive times a negative. So since the signs are different, the answer will be negative, and 7 times 5 is 35. Okay, number 7, this is a division symbol. Sorry if it's hard to tell based on my zoom. I'll try to come in a little bit. Okay, now when we're dividing a fraction, we have to flip, so to speak. We change this to a multiplication sign, and we flip the fraction upside down. Now, after you flip the second fraction, and only the second fraction, upside down, you can cancel some things out. For example, 3 and 27 are both divisible by 3. So 3 divided by 3 is 1. Negative 27 divided by 3 is negative 9. 2 and 8 are both even, so I can divide them both by 2. Negative 2 divided by 2 is negative 1. 8 divided by 2 is 4. So I get negative 1 times negative 9, which gives me a positive 9. So when the signs are the same, they're both negative, the answer is positive. And 1 times 4 is 4. Okay, on this one, we're already in the multiplication mode, so we don't have to do any flipping, but we can go ahead and reduce because 10 and 20 are both divisible by 10. Divide that by 10. Divide that by 10. 3 and 15 are both divisible by 3, so divide that by 3. Divide that by 3. So we get 1 times negative 2, which is negative 2, and 1 times 5, which is 5. Okay, number 9. We have to flip the second fraction because we're dividing. So we keep the first fraction as it is, change division to multiplication, then we flip this inequality to be 34 over 30. Now the 17 and the 34 can both be divided by 17. And the 12 and the 30 are both even, so we divide that by 2, divide that by 2. Oh, actually, they could have been divided by 6. But sorry, now I see 6 and 15 are both divisible by 3. So I can divide that by 3, divide that by 3. So I get 2 times 2 on top and 1 times 5 on the bottom. Okay, number 10, before we do any canceling out, we'll need to flip the second fraction. So we flip it to be negative 20 over 4. It does not actually matter where you put the negative sign, so it's okay if you keep it with the 4 or not. 5 and 20 are both divisible by 5. 4 and 14 are both divisible by 2. So we get 7 times negative 4, which is negative 28, over 2. And it's uncommon this happens, but sometimes even if you've reduced correctly here, you can reduce even farther once you combine them. And negative 28 divided by 2 is negative 14. It's got to be negative because they have different signs, one negative and one positive. Okay, we'll keep rolling on the back. So no canceling out can happen here. 2 and 3 have nothing in common other than 1. Same for 5 and 1, so I just say 2 times 1 is 2, 5 times 3 is 15. Okay, when there's a mixed number involved, you'll first want to change it to an improper fraction. So 1 times 2 is 2, 2 plus 1 is 3. And again, there's nothing we can cancel out. 3 and 2 have nothing in common, 5 and 3 have nothing in common, so we just do 3 times 3 on top, 5 times 2 on the bottom. And we'll follow the same method with 13 because we got to change the mixed number into an improper fraction. 3 times 6 is 18. 18 plus 5 is 23. Nothing that can be canceled out. So on top we do 1 times 23. On the bottom we do 4 times 6. Okay, on this one we're already multiplying. 7 and 3, nothing will cancel out, but 2 and 10 are both divisible by 2. So we get 7 times 1 on top, or I'll say negative 1, so it's negative 7 on top. 5 times 3 is 15 for the bottom. Okay, number 15, we're dividing, so I'll have to multiply by the reciprocal. So I'll keep the first one the way it is, change division to multiplication, and flip this over to be 2 over 1. No canceling out can occur, so I just multiply. 1 times 2 on top, 3 times 1 on the bottom. 16 will be similar, since it's division. We'll have to multiply by the reciprocal, so we flip this one upside down and make it 3 over 2. And that prevents us from being able to simplify or cancel out anything. So we'll do 3 times 3 is 9, 8 times 2 is 16. Okay, 17, our first step is to move this into improper fraction form. 2 times 2 is 4, 4 plus 1 is 5. So I get 3/4 divided by 5 over 2. Then I change it to multiplying and flip the fraction to be 4 over 5. Sorry, this would be 2 over 5, my fault. So that was 5 halves. Excuse me. So 3 over 5, or excuse me, 3 and 5 can't cancel, but these are both divisible by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. So we get 3 on top, and 2 times 5 is 10 on the bottom. Okay, on this one we're also dividing, so we'll keep the first one the way it is, change it to multiplication, and flip it upside down to make it 10 over 2. Now this will cancel out the 5 on the bottom here, the 10 on the top here. Negative 1 times negative 2 is positive 2. 1 times 2, hold on just a second, I think I made a mistake somewhere. Let me back up. Oh goodness, I see it right here. Double check the rest. 10 over 3. Okay, I think that was it. Yeah, we're good. And then 1 times 3 is 3. So we get 2/3 for that answer. Okay, the last thing you've got to remember how to do is find the reciprocal. The reciprocal just means the fraction gets flipped upside down. So one like 19 is very straightforward. You literally just move the 5 to the top and the 9 to the bottom. Now 20, before you do the flipping, you have to change it to be an improper fraction. So 6 times 7 is 42. 42 plus 2 is 44. So negative 44 over 7. Now these are equal. To get the reciprocal, we flip it. And you can put the negative with the 7 or the 44, doesn't matter. And with 21, you might be like, how do I flip a whole number? Fair question. First, we write the whole number as a fraction, because we can always put a whole number over 1. Now, we flip that fraction over, keep the negative sign, we get negative 1/5.